All right, so we currently are going to look at what's called the first derivative test. And it's one of those things where you really want to understand it conceptually. Don't just focus on memorizing it word for word. Understand what it is, and it's going to be a lot easier to use. So a couple things we want to kind of recognize. So remember, the derivative gives us the slope of the tangent lines. And the slope of the tangent line gives us the instantaneous rate of change for that function. So remember that a line with a positive slope is an increasing line. A line with a negative slope is a decreasing line. So we're going to take all that information and kind of put it together to create this thing called the first derivative test. So we've got a tangent line right here, right? The tangent line to this curve. This tangent line has a negative slope. That negative slope tells us that our function has an instantaneous rate of change that is negative, which means it's a decreasing function. Okay, so negative slope corresponds with a decreasing function. We can do the same over here. All right, what about over on this side? We have a tangent line right there with a positive slope, and we can see that corresponds to where the function is increasing because the instantaneous rate of change is positive, so it's an increasing function. So basically what we're going to develop here is a tool to figure out when our function is increasing or decreasing precisely. Right? Not just by looking at a graph, but we know exactly the intervals over whether it's increasing or decreasing. And you might think, why don't we just look at the graph? Right? Why don't I just look at it? We've got this nice graph here. Well, if the values that you have to find are messy, like square root of 2 or 7/11ths or some kind of weird fraction or decimal, you're not going to be able to find them by just eyeballing it on the graph. So we want to find the exact values where these things change. So basically, we're going to create the first derivative test by finding the first derivative and then getting the information that we just talked about and using it in a very organized way. So we're going to use the sine charts that you learned in your previous semesters about how to figure out when a function is positive or negative. And we're going to apply that to the first derivative because figuring out where the first derivative is positive or negative, as the way we just explained, will tell us if the original function is increasing or decreasing. So now we're going to start heavily using the derivative, the first derivative, and coming up soon, we're going to be using the second derivative. So it's really important at this point that you be very careful about labeling your functions and always make sure when you go back and you grab either the derivative, the original function, or the second derivative, just double check that you're grabbing the right function because it's very easy to grab the derivative when you really mean to grab the original function, or you grab the original function when you really mean to grab the first derivative. These are super easy mistakes to make. So always stop and go, okay, what part of the problem am I in? Oh, then for this part, I want the original function. Or, oh, for this part, I want the derivative, because it's easy to grab the wrong one. So we're going to use this connection between positive derivative means increasing function, negative derivative means decreasing function, to pin down precisely where a function is increasing or decreasing. So let's go over and take a look at that. Okay, so what do we have here? We have the original function. So we're interested in the function f of x equals 2x cubed minus 15x squared plus 24x minus 5. Okay, and we're going to use the first derivative test, so it stands to reason we should probably calculate the first derivative. So we've done that here. It's polynomial, right? Pretty straightforward to do. So the derivative of our function f is 6x squared minus 30x plus 24. So I've got that derivative taken easily enough. So if you think about it, if a function is going to change from increasing to decreasing or from decreasing to increasing, it's going to happen where? It's either going to happen at a maximum or minimum value, or if you have a function that is discontinuous, it could happen at things like a vertical asymptote, something like that, okay? So it turns out, looks like we're looking for our critical numbers because those are going to give us the places where the increasing or decreasing behavior of a function is possibly changing. So we know that this function is not going to have any undefined points. If you're doing a problem with a rational function, also find where your function is undefined. But we're starting off with an example so that we can kind of get things conceptually, and then we'll dive in later with more hardcore examples. So I take this function and I set it equal to 0, and we solve that. And it looks like that happens at x equals 1 or x equals 4. So now what you need to do is go back and make the sine charts that you did in previous semesters. So what we do is we take our numbers here, right? 1, 4. There's ways of organizing these horizontally, ways of organizing them vertically. You do whatever works for you as long as it's organized and you understand what it's saying. Okay, so we have 2 divisions in our number line. If you take a number line and you create 2 divisions, you now have 3 pieces, right? You have 3 intervals that you have to figure out what's going on. So how do we figure out where we're positive and where we're negative? Well, one possibility is you look at the graph. If you're not sure, sometimes it's hard to tell. Maybe points are really close together. What you do is you take a test point, right? Take something in between and test it and see what's going on over these intervals, right? So if we do that, we get plus, then minus, then plus. That means that our function is, so reading this, we can see that our derivative is negative between 1 and 4. That means that our original function is decreasing from 1 to 4. So that's our conclusion here. F of x is decreasing from 1 to 4. And our derivative is increasing if we look up here from negative infinity to 1 and from 4 to infinity. So our conclusion is that f of x is increasing on negative infinity to 1 and 4 to infinity. So let's take a look at the graph and see if we can sort of visually see this information. Okay, so here's our function, and it looks like everything's checking out. From a negative infinity to 1, our function is increasing. From 1 to 4, our function is decreasing. And then from 4 to infinity, it's increasing again. Let's take a look at the derivative at the same time and see if we can see that playing out. So here we have our derivative, right? Well, if we take a look, if we go right along here is where we... if we take a look here, right here, our function goes from increasing to decreasing, and we can see that that's happening at a local maximum. So that's a clue to having a local maximum, is that your function goes from increasing to decreasing, and it's continuous. Probably makes sense. There'd be a local maximum there. So what's happening? Our function right here is increasing, and our derivative is positive. We can see it's above the x-axis, so right up here, right until we get to 1, we have a positive function. Right here it hits 0. Remember, the blue line is the derivative, so we get a horizontal tangent line right there, and then here we go negative, and our function is decreasing over that range. And then at 4, we get the same type of thing where our derivative goes from being negative to positive, and sure enough, our original function goes from decreasing to increasing. So if you spend a little time with this when you're doing these functions and their derivatives, if you can just, sometimes it just takes 5-10 minutes, try to do this where you're looking at the derivative and interpreting that derivative in terms of the original function. This can be a really helpful tool to develop, because while other people are still trying to go through and figure out what's going on, you already pretty much understand what's going on in this problem, because you're looking at the derivative and going, oh, here I'm positive, so this part of the graph for the original function should be increasing. Here my function is negative, so over this area, if my derivative is negative, that means my original function should be decreasing, right? And you can put all this together, and it just makes the algebra and the calculus a whole lot easier to work through if you already kind of understand what's happening.